Next, we'll take a look at solving log equations. So to solve a log equation, the first thing we want is to get at most one log on each side of the equation. If there's only one log on one side, then we're going to get rid of it by rewriting the equation with exponents. But if there's a log on each side, then we can cancel them. And then we'll go ahead and solve. So we'll take a look at examples where both of these processes come up. Solve log to the base 2 of 2 plus log to the base 2 of 3x minus 5 equals 3. So an equation has two sides, and on each side of the equation, we want at most one log. It's okay to have no logs, but it's not okay to have two logs like we have on the left side. So what we need to do is we need to combine these, and the way we combine them is by using one of the three log properties. So we remember that adding the logs is the same as multiplying. So we can combine these as log to the base 2 of 2 times 3x minus 5 is equal to 3. How do we get rid of the log? By rewriting this using exponents. So we know that 2 to the third power, or in other words 8, would be equal to 2 times 3x minus 5. And now this is a simple equation that we can solve. We'll distribute. 6x minus 10 is equal to 8. We'll add 10 to each side, and we'll divide by 3. And we have our answer, x is equal to 3. Let's try another. Solve 2 times natural log of x plus 3 is equal to 7. So we want to get at most one log on each side. And we see that we have a bit of work to do to isolate the log. We'll start by subtracting 3 from each side. That gives us 2 times the natural log of x is equal to 4. And to get rid of this 2, we'll divide both sides by 2. That tells us that the natural log of x is equal to 2. To solve, we're going to go ahead and rewrite this using exponents. Now, just as a reminder, whenever we're using a natural log, that means the base is e. I'm just going to write it in so that we can see it. So what do I know? I know that e squared is equal to x. And so that's our solution. If you wanted to find a decimal approximation for that, e squared is approximately equal to 7.389, which we did on our calculator. Let's try another. Solve 2 times the natural log of 6x is equal to 7. So we're going to start by dividing both sides of this equation by 2, and that tells us that the natural log of 6x is equal to 3.5. So now we have one log on each side, or one log. So what we'll do is we'll get rid of it by rewriting this with exponents, just like we did previously. Natural log, the base is understood to be e. E to the 3.5 power is equal to 6x. And so dividing both sides by 6 will give us the value for x. And so we can take our calculators and approximate this. E to the 3.5 power divided by 6 would be about 5.519. Let's try another. Solve log of 3 plus log of x minus 4 equals log of 5x plus 2. So on this right side of the equation, we have one log, but on the left side, we have 2. And so what we need to do is we need to combine them. Like we did before, we know that adding the logs is the same as multiplying. So we can rewrite this as log of x, let's erase that. Log of 3 times x minus 4 equals log of 5x plus 2. Now this is the first example that we've come across where we have one log on each side. Up until now, we only had one log on one side of the equation, and so to get rid of it, we had to rewrite the problem using exponents. But when we have a log on each side, we can just cancel them. That leaves us with this equation to solve. 3x minus 4 is equal to 5x plus 2. And let's just go ahead and solve that. We have 3x minus 12 is equal to 5x plus 2. We'll subtract 3x from each side, and we'll subtract 2 from each side. And we'll divide both sides by 2 to finish this off, and we have a solution of -7. Now, when we have our solutions to a log equation, one thing we have to do is make sure that our solution gives us values that are in the domain of the log function. So, for example, coming back to our first solution, we have a value of x is equal to 3. If we put a 3 here, we'd be taking the log of a positive number, which is fine, something that's in the domain of the log function. Here, we got a solution of 5.5. If we place it into our original equation, we're taking the log of a positive number. It's in the domain of the log function. However, in this example, we have a solution of -7. Notice that if we put -7 here, we would be taking the log of -11. And negative numbers are not in the domain of the log function. So even though we got a solution to the equation 3x minus 12 equals 5x plus 2, this solution is not a solution to the original equation. And so this equation has no solution. Here's one for you to try. Solve 2 times the natural log of x plus 1 is equal to 12. And let me help you get started. Remember that you want to make sure you have the log by itself before you start. So the very first thing you're going to want to do is to divide both sides of that equation by 2. When you get your solution, don't forget to check to see that your solution is in the domain of your function.